Okay, this is part 3 of a poor man's guide to how to fight cancer, also called the Cancer Picture Book. And again, this is not just a regular book. I'm adding my commentary to it and whatnot, so it's a bit different. We'll go over this one slide. This was the last slide from part 2. We're in part 3 now. I'll just show you this because this is one of the most important things. If you only get one slide out of this whole book and series of lectures, this is the one. So the point again is our bacteria. Anaerobic bacteria just runs on glycolysis to metabolize glucose, a 6-carbon sugar, to pyruvate. Waste product is lactate, okay? A normal cell is not like that. A normal human cell runs on oxygen. Oxygen for aerobic metabolism. It's called oxidative phosphorylation in the mitochondria. So the point is you make tons, 18 times more energy with oxygen as you do anaerobically. But a cancer cell is a cell that wasn't getting enough oxygen. And while most cells die, suddenly is to die by necrosis, slowly is to die by apoptosis. Apoptosis allows time to recycle the inner contents of the cancer cell. So anyways, the uniqueness of the cancer cell is that the cell that's dying, apoptosis is to recycle the cell that's dying. A cancer cell does not die. A cancer cell basically transforms itself to become like an anaerobic bacteria. So that's a key point. Everything I say is a little bit of an oversimplification, but that's what you need to know. Okay, so the cancer cell then will take the glucose, metabolize it to pyruvate, and then excretes lactate as a waste product. It also pumps out protons into the extracellular matrix, the space around the cancer cell. So that makes it acidotic. Acidic pH means how acidotic an area is how many protons are floating around. Okay, so there's a lot of protons in the extracellular space around the cancer cells. The acidity of the extracellular matrix around the cancer cells is good for the cancer. It makes the immune system dysfunctional so that it will not be able to remove the cancer cell. The acidity also prevents the neighboring cells from growing. So this gives the cancer cell an advantage that it can grow and proliferate. Okay, that's why this is called the tumor microenvironment, the space around the cancer cell. That's why you want to avoid things that cause acidosis, things like meat, okay? That's why you also want to avoid, excessive dietary salt, sodium chloride, because the chloride also leads to a mild metabolic acidosis because the chloride ions displace bicarbonates in the blood. They have to maintain a set number of negative ions in the blood. All right, so anyways, what else happens? What else is unique about the cancer cell? Because it needs more glucose, it will have more glucose receptors on its cell membrane, and even glucose type 1 receptors that just let that glucose come on in. A cancer cell will often use 100 times more glucose than will another normal cell. In addition, it'll have more CD36 receptors to take in more fat. That's why a high dietary fat approach is not good for cancer. What does a cancer want to do? A cancer wants to double itself. And when I say double itself, that means it needs to make a complete copy of all its plasma membranes, organelle membranes, of all its enzymes, of its electron transport system in the mitochondria. So that's why it needs tons of building blocks for synthesis. So a high-fat diet is going to provide more fat. Here, I think this paleo diet for cancer is a bad idea based on the pathophysiology. In addition, it's going to have more receptors for iron. They're transferrin, that's the iron transport protein in the blood, transferrin binding proteins to get more iron into the cell. And that's why sequestering iron can help prevent the growth of cancer. Just like a bacteria cannot grow without iron, a cancer cell can't either. And we've talked about an egg. An egg has an eggshell that's permeable to the air, permeable to bacteria, but the bacteria cannot get through the egg white to the yolk, to the embryo, because there's no iron in the egg white. And that's how our human body prevents bacteria from growing. So what I'm saying is you can do the same thing on a macroscopic scale by depriving the cancer of iron, minimizing your dietary intake of iron, checking your serum ferritin, wanting it between 25 to 80, and if it's not there, then donating blood to get it lower. And by the way, this is not medical advice. I'm not your doctor. I'm not a cancer doctor. I'm just teaching about cancer pathophysiology. You have to work this out for yourself and work with your own doctors and stuff, but I'm helping you to have a general understanding of cancer pathophysiology. Okay, what else? Glutamine can come in the back door of the mitochondria, and Krebs cycle can run entirely off of glutamine. So the point is, if you were to minimize your glucose, you'd be double screwed, because not only would you still be screwed because the glutamine converted to glutamate will still allow Krebs cycle to run and all the mitochondrial pathways related to energy production, but you need glucose for your brain, so you're not going to work depriving your brain of glucose. There's going to be a lot more insulin-like growth factor receptors. They're upregulated, meaning increased amounts are placed on the plasma membrane of the cancer cell. So what this means is the cancer cell is hypersensitive to those growth factors. And that's why, regular people, the way they think is just stupid. They think socially, and they think in what I would call an analog. 1 + 1 = 2. That's not what it's about. What I mean by that is a cancer will have exponentially more receptors for all this stuff on its plasma membrane. And that's why you want to totally deprive it. You don't, this idea of a cheat day on the weekend, that's just stupid. You don't want to give cancer anything that it needs to grow if you can avoid it, okay? So this is a whole bunch of things we just talked about. Number 1, avoid dietary salt because it causes a low-grade metabolic acidosis. Avoid meat because it causes a metabolic acidosis. Avoid meat because the amino acids, especially the leucine and the methionine, which are present in increased amounts in meat, help activate mTOR, the pathway that gets cells to replicate, okay? Avoid iron because that'll also activate mTOR, and by depleting the cell of that, you can help to shut off mTOR, okay? Minimize your excess dietary fat because that also can help to shut down mTOR because it causes insulin resistance, and the elevation of insulin also elevates insulin-like growth factor, which leads to elevation of mTOR. And there's increased receptors on the plasma membrane of the cancer cell for the insulin-like growth factor and for activation of mTOR, okay? All that stuff is good to know. Let's see what else on here. I think that's the key for that. Oh, sodium does another thing. The dietary sodium will lead to activation of platelets, and they'll form a coating around the cancer cells that have reached the blood, and they'll hide them from the immune system. And this acidosis, as we spoke about before, is also relevant because it impairs immune system function. So just right there is a whole bunch of things you could do to have a chance at slowing down the growth of cancer. Okay, now I'm going to talk a little bit about mechanisms of what causes cancer, and this is the Warburg effect. Warburg was the biochemist who won the Nobel Prize in 1931. He's from Germany, Otto Warburg. He's very good at measuring things real precisely. And what he found is when he had human tissue cells in culture, when they're deprived of oxygen, they will mostly die, but some can turn into cancer if you deprive them by 35% or more oxygen. So anyways, this just shows how this can happen in the human body. A person inhales asbestos, working with that old insulation fiber. Then the body forms an inflammatory reaction around it to wall off the foreign body within the body. And within that inflammatory reaction, you'll form fibrosis, scarring, collagen, and some normal lung cells get trapped in there and they become hypoxic because there's not good access of the oxygen to them, and some of them may transform into cancer. So that's showing how hypoxia leads to a Warburg effect, leads to cancer. The majority of cells will die, let's say by necrosis, fast, apoptosis slowly, but some may transform into cancer, okay? And this is very helpful. This is the metabolic theory of cancer, and it shows you how this can happen in lots of other locations. So here it is, the same situation with fatty liver. Person eats the modern SAD diet, they get a fatty liver, the fat gradually becomes inflamed, so it goes from NAFL, non-alcohol fatty liver, so that's fatty liver not due to alcohol. Then you get NASH, non-alcohol steatohepatitis, and the itis means inflammation. Inflammation then progresses to fibrosis. Fibrosis is scarring. It's the laying down of collagen, okay? The collagen scars things off and it impairs blood flow. So within that, it eventually, the progressive fibrosis becomes cirrhosis. There'll be pockets of liver tissue that are not dead, but they're not getting enough oxygen. And when they don't get enough oxygen, they can transform by Warburg effect into cancer. So there's how you can get liver cancer from cirrhosis. And like we spoke about in a previous recent lecture on fatty liver is now one of the most common causes of patients going into full-blown cirrhosis, dying of liver failure, going for liver transplants, developing liver cancer. Okay, and what I'm showing you is this common mechanism of progressive scarring, fibrosis causing ischemia, lack of blood flow, and that leading to Warburg effect in cancer. And this hardly gets researched because it's seen as there's not much money in it. Everything tends to go by the old-fashioned somatic mutation theory, even though it's been largely refuted, by the Genome Atlas Project. Okay, it's kind of a bit of a joke. Okay, but old theories die hard when they're profitable. Here I just want to show you the words if you want to see the words. The Cancer Genome Atlas Project, and it's a little bit of a joke, a little bit of an acronym, because those are like the base pairs in DNA. Thymine, cytosine, guanine, and adenosine. Okay, adenosine. Okay, the somatic mutation theory failed. Okay, they couldn't show consistent patterns. The metabolic theory of cancer, MTC, it also explains why, for example, look at Papua New Guinea and the Japanese. They're smoking like chimneys, but they don't have much lung cancer. It's because they're eating a healthy diet. Whereas the Americans who smoked similar amounts or less had much more lung cancer, over 6 times more than Papua New Guinea, because they have the high-fat diet on top of the smoking that will make the cells hypoxic, okay? Hypoxia means lack of oxygen delivery. So hypoxia and ischemia are very similar, as kind of for our intents and purposes of having this, essentially the same meaning, okay? The Papua New Guineas were eating mostly sweet potatoes. They're only 4.5% fat. The Japanese were eating mostly rice at that time, only 1% fat. So they had very low-fat diets, and that gave them better blood flow. Okay, here's a great book by Caldwell Esselstyn. He's the doctor out of Cleveland Clinic. He was an endocrine surgeon, cancer surgeon, and then he became the expert of dietary treatment of atherosclerosis. Basically, Esselstyn's a smart guy. I looked at a book and he says, all these people that live around the world in plant-eating communities, they don't have any atherosclerosis. None. No coronary artery disease. Maybe if Americans ate that way, they wouldn't have any coronary artery disease either, okay? And so he wrote this book originally, and then he later did a paper published, I think it was July 2014 in the Journal of Family Practice, 198 patients in a row who followed the diet, had 0 cardiovascular events. One patient who didn't follow the diet did have a recurrent cardiovascular event. And there's nothing even close to this. You know, this makes coronary artery bypass, graft surgery, and stenting look like a joke, okay? It's good to know that, okay? And then they tried to do a competitive study like the Lyon study, which was basically, an optimized version of the Mediterranean diet. And Esselstyn's diet was, I forget the exact number of times better, but it was something like 30 plus times better, orders of magnitude better than that optimized Mediterranean diet. Mediterranean diet is basically a joke. We've talked about that before. Okay, Esselstyn's diet, same old thing. Low fat, low sodium, 100% vegan diet. No meat, not one bite. No oil, not one drop. Okay. Then I got some quotes from Esselstyn coming up here. Esselstyn says, coronary artery disease is virtually non-existent in the Tarahumara, the Papua New Guinea, Okinawa, Central Africa, and rural China. And then he says, nitric oxide is the most powerful vasodilator in the body. That's the one made by the endothelial lining cells of the arteries. Nitric oxide is the life jacket of your arteries. The number one goal of good arterial function is to maintain adequate amounts of nitric oxide. Okay, as we get older, our arteries produce less nitric oxide. But the body has another way to produce nitric oxide, from plants. Eat green vegetables at every meal to keep your arteries bathed in nitric oxide. Okay. Couple things about that. As people get older, they make less nitric oxide, but some of that's also because they've been eating the standard American diet, diminishing arterial flow. Populations where they eat plant-based diet their entire life, they have the same blood pressure as a teenager as in their 70s. So you can maintain much better nitric oxide if you take good care of your arteries, eat the healthy diet. Let's see, what else does he talk about in here? He totally just emphasized nitric oxide, nitric oxide, nitric oxide. I went and trained at his course, and I talked with him, and it was kind of funny because, I have all kinds of questions and experience with atherosclerosis. I say, well, what about this? What about this? And he's like, Pete, I'll talk to you later. He goes, don't confuse people. All they need to know is nitric oxide and follow that and look at good results. You start talking about all this other stuff, you just confuse people. So that was kind of funny. Okay, so let's show some of the different ways you get more nitric oxide. Sunshine gives you more nitric oxide. This right here is a picture of what happens when you eat a plant food. Let's say a piece of salad. It contains nitrates, NO3, all right? And then they are metabolized by the bacteria on the back of your tongue, and that converts them into nitrites, NO2, okay? And then they go down to your stomach with the stomach acid, and they're converted into nitric oxide, NO, all right? So what's also relevant about this is you don't want to be using toothpaste or mouthwash with F- in it because those will kill the bacteria on the tongue, and then you won't make this conversion, and you'll get less of this nitric oxide. The nitric oxide is a vasodilator. It goes throughout the entire body. Systemic means throughout the entire body. And it vasodilates the arteries, and it lowers the blood pressure. Sunshine also on our skin causes the release of more nitric oxide into our blood, sort of a systemic vasodilator to lower our blood pressure. And so this is why you'll hear Caldwell Esselstyn sometimes say, if you really want to increase your nitric oxide, just sort of chew on greens all day long. And there is something to eating a lot of greens. Besides Caldwell Esselstyn talking about it, that lady Ruth Heidrich, PhD lady who's decades long, like 40 plus years survived metastatic breast cancer. She eats big salads, and she healed some major comminuted fracture of her femur. That's a thigh bone fracture of her femur. You would think she'd never walk again. She healed that just in a couple of months, eating all her salads every day. And that guy Chris Wark, who survived metastatic colon cancer, he's a big giant salad eater. So I saw that as a kind of a common pattern of people who heal well, and I would bet that the increase in nitric oxide is part of that. And when you hyperoxygenate your tumor microenvironment, your tumor milieu, you are more likely to, suppress cancer growth. That favors the surrounding cells if there's good oxygenation of the area compared to the cancer. Cancer does better in a hypoxic, ischemic, acidotic milieu microenvironment. Okay, here's a picture drawn of Dr. Esselstyn with his son Rip, and I kind of joked about it that Esselstyn kind of reminded me like of an Old Testament God, totally unflinching. Thou shalt not eat meat. Thou shalt not eat oils. And so that's the way it has to be. Think biblical. You don't eat meat. You don't eat oils. Okay, no dairy, not one drop. That's what gets good results. In moderation doesn't work. Esselstyn says moderation kills. Half-ass leads to worse than half-ass results. Okay, let's see. Oh, there's some other famous survivors, and Ruth Heidrich, 100% vegan, Janet Murray Wakeland, and Ruth Heidrich and Janet Murray Wakeland, they're almost raw vegans, almost completely. Lorraine Day was another real famous vegan who survived metastatic breast cancer for decades, and she's almost raw too. So all three of them have almost gone to raw veganism. They don't necessarily start out that way. Dr. McDougall recommends starch is the best food for humans, and he actually recommends limiting fruits to about 1 to 3 servings a day because in his experience, people tend to overeat them and potentially can get fat on them. And there's other issues with fruits. They're more expensive. They don't store so well, and nowadays there's the whole appeal business, which is not resolved yet exactly how to best handle that. For myself, I'm even fussier than this. I won't eat anything with MSG, MFG, aspartame. Won't cook on aluminum things. Minimize iron. Okay. I actually eat about 35% fruits currently. And actually, I would tell you, I'm fussier than these other guys because guys like McDougall, Esselstyn, T. Colin Campbell, they sort of think, the end line of optimal nutrition is you got good blood flow to the heart. Whereas for me, the end line of optimal nutrition is do I have good blood flow not only to the heart, to the brain, but more importantly, too, have I avoided all the toxins that are associated with decreasing cognitive decline, the mitochondrial inhibitors, all the stuff that you see. There's a lot of bad stuff in non-organic food. There's a lot of bad stuff in tap water. There's a good reason to try to avoid it. Okay, so here's a tumor milieu, meaning the tumor microenvironment. And the acidosis around the tumor cell, because it pumps out the protons causing acidosis, that puts the immune system to sleep. So it cannot remove the cancer cell, okay? So there's acid pumped around it. In this case, I'm using it like a moat, like a castle with a moat around it, all this blue stuff. Oh, another thing is, I did send out to the newsletter to everybody who requested a newsletter, and I sent one to myself, and I don't know if it's just a question of time or what, but I couldn't see the images on the newsletter. I tried sending it, in 2 different file formats, and I couldn't see the images. So I don't know if you guys could see the images or not. If you watch these videos, you'll see the images here. So I'll show you the images here. I thought about sending it as an attachment, but attachments are kind of a pain in the butt, and people probably don't want to open those. So I haven't figured it out. In the future, maybe I'll just send a newsletter with no. I probably should make a separate video about this. Maybe I'll send a newsletter though in the future with no pictures. I don't know. I haven't figured out what to do about that. I'll have to think about that. All right. Well, anyways, around the cancer cell, there is the tumor microenvironment or the tumor milieu, and I said it's like a moat around a castle for defense. And all that acid prevents the immune system from being able to come in and kill the cancer cell. Okay, and the surrounding hypoxia, lack of oxygen, prevents the surrounding cells from growing. So this is how cancer basically kicks ass on all the cells around it. All right, and this is called the hypoxic acidotic tumor milieu or tumor microenvironment. Okay, now here's a cancer cell dividing. And this is a mitotic daughter cell from the cancer cell. So as the cancer cell replicates and proliferates, it produces what are sometimes called the cancer daughter cells. In addition, though, the cancer cells within the tumor will have cancer stem cells. And these cancer stem cells will quite often grow very slowly. And that's a big deal because cancer chemotherapy tends to kill fast-growing cells. And you can only give chemo for a certain number of days, let's say a week, 2 weeks or something. The point being is, if these cancer cells are growing real slow, the stem cells, there's a good chance chemo's not going to kill them. And the cancer stem cells are good at pumping chemo out. So you understand how the patient's screwed? That the chemo will come in and it'll kill off all the daughter cells, but it won't kill off the stem cells quite often. And then the stem cells come back, proliferate, often grow back more rapid than before, and just kill the patient. Okay? And you can't give chemo every day. Again, chemo is like playing chicken, as Suresh Mukherjee said in his book, Cancer, the Emperor of all maladies, of all diseases, because to give all this chemo, you almost have to kill the patient. And then you have to pull off at the last minute. And if you don't pull off soon enough, the patient dies too. And it suppresses the immune system. And then the stem cells are often alive. And then the stem cells come back and kill the patient. So the nice thing about eating a healthy diet and living a healthy lifestyle and getting your exercise, managing your stress, and praying to your God is that you can do that stuff every day. And it's free. Okay? Free. Okay? Lorraine Day calls this God's way of healing. All right? It's free. And that's why no one wants you to know about it. Okay, and I'm not a cancer doctor. I don't have any cancer patients who I'm treating with this, but I certainly, gosh, do I wish I knew this back when I had a chance to heal my mother, which was, many, many years ago. I was a young guy back then. I was still in residency when she died. Well, I actually was just finishing up. I didn't know this stuff. And I was like the perfect student, 99%, best of my class, you name it. I was probably the best radiology resident in the whole United States. And I say that because it's not in the books. That's the point I'm making. None of the answers to these questions are in the books. The medical books do not have the answers. You can memorize them from front to back, which I did, and it's not in there. That kind of pissed me off because I sort of gave up my whole life to memorize those books. And then the answers aren't there. It's like, what the hell? You have to go outside of those books, into the medical literature, and into the nutrition literature, and into the epidemiology literature. Okay, so anyways, we just talked about how do you fight back against this hypoxic acidotic tumor milieu. And you avoid things that cause acidosis, like the meat, like the salt, for example. You avoid things that cause hypoxia, anything that's going to thicken the blood, the things that cause leaky gut, high-fat diets, okay? And here we are saying, cancer stem cells are often resistant to chemotherapy. That's a big deal. Fruits and vegetables are relatively alkaline, so that'll help favor the normal cells and help get the immune system to work better. For this book, I pretty much had about one picture per page. So I'm not going through the text verbatim, but I'm giving you the gist of all this stuff. And so if you have cancer or you got anybody in your family who has cancer, this helps you to get it, to know what you could do to help yourself. So this is called stress activates platelets. So when you're psychologically stressed, for our animal ancestors, that kind of meant usually, being the way you remembered in med school is being chased by a tiger in the dark. So your pupils dilate, you're in the dark, chased by a tiger, you get all this energy to run, go climb a tree or something. And in the process, you release these acute phase proteins from the liver, and the platelets become more activated. In case a tiger claws you, you won't bleed to death. All right, but these activated platelets, they can surround a metastasizing cancer cell. So here's a cancer cell that's got into the blood, and the platelets will encircle it. And then when the immune system comes and tries to find it and detect it based on what's expressed on its plasma membrane, it can't contact the cancer cell because it's surrounded by platelets. And they almost function paradoxically like escorts to take the cancer cell to go metastasize somewhere where it wants to go, to the liver, to the lungs, to the brain. Those are common spots of fatal metastases. Okay, so that is bad. And so that's a big reason why excessive stress is bad, because it makes platelets sticky, and the sticky platelets can hide cancer from the immune system. Okay? Stress does other thing. It increases cortisol. Cortisol is a hormone which suppresses the immune system, so they're less able to remove cancer cells. Stress also elevates the hormones adrenaline and noradrenaline. They're also called epinephrine and norepinephrine, and they can function as siderophores. Sidero means iron, 4 means to transfer, and they can potentially be transferring iron to the cancer cells. That's what you don't want, because they can do that to bacteria. That's another reason why you get more infections when you're stressed out, is because you're enabling more transfer of iron to bacteria, for example, and your immune system's not working as well due to the suppression of the cortisol. Okay, so it's a double bad. And then also, here's another screw job, that high dietary sodium and high saturated fat, they both can cause activation of platelets, okay? So what kind of a stupid meal would that be? Like, let's say, I used to think eating pizza was great because it tasted good, but look at that. You got tons of saturated fat and you got tons of dietary sodium. Not good. Okay, now we're going to talk a little bit about peak performance. Okay, so peak performance, for getting into the zone to perform at your best at something, you want to be sort of in the middle. If you're not at all stressed and you're not at all enthused, motivated, excited, then you're like a slug. You don't got energy to do anything. But if you're overly stressed and freaked out, then you can't do much either. So I would actually say the perfect spot to be is somewhere around here. They might say way up in here, but the point being is this is sort of a flow state. So you can be highly functional, but you're kind of mellow. You want to try to keep peace of mind. And one of the best ways to keep peace of mind is simplify your life. Avoid BS. Avoid nonsense. Avoid ignorant, negative people. And also religion helps you get a sense. And religion, in a sense, you pray to your God and you say, whatever may be. I'll be the best person I can be while I'm alive. I'll do the best I can. And whatever happens, happens from there on out. Okay, here's another, here's another example of what you can do. So this shows a seesaw, and the seesaw is between the growth pathway, which is really key thing is mTOR, mammalian target rapamycin, also called mechanistic target rapamycin. And mTOR is like a contractor getting ready to build a building. And the contractor says, okay, before we can build, do we got everything we need? Do we got the bricks? Do we got the cement? Do we got the wood? Do we got the windows? Do we got everything we need? Okay, and the rate limiting steps for making a copy of another human cell is typically, do you have methionine and leucine? Those are key amino acids that are present in much higher amounts in meat, number one. Number two, do you have enough iron? You need iron to put iron in all these enzyme systems, and it goes in the electron transport system. Do you need iron? Okay, number three, do you have elevated enough levels of insulin-like growth factor and insulin, which are usually increased by eating a lot of dietary fat? Okay, so you can avoid all those things and thus cause less activation of mTOR. mTOR is not going to say go ahead and divide because the cell has to make an exact copy of itself. The cell has to double itself. That's a very important point. For preventing cancer, you want to know that. Inhibition of mTOR as well as optimization of immune function, those are two major pillars, cornerstones of improving survival in cancer. And number three, another giant one is avoiding estrogenics, okay? Because the estrogenics, they cause proliferation of cells in the breast, in the prostate, and in the uterus. The male prostate is kind of like the female uterus. It's sort of an embryological developmental equivalent, if you will. All right, and so then what's the next thing? The next thing is exercise a lot. We talked about Ruth Heidrich running all these triathlons and marathons, setting records and stuff. We talked about Janet Murray Wakelin running in 1 year 365 marathons. She ran a marathon every day. That's how fast she could heal. Think about it if you ran a marathon. You'd be in pain for 2 weeks, okay? She could run a marathon every single day for 365 days in a row, okay? That's what a raw vegan diet can do for a person. Okay, and you don't have to be raw vegan. Like I said, the starch is good. McDougall recommends starch. He's got a lot of experience with cancer patients. What else? We talked about sodium makes things worse. Refined sugars make things worse too. So you don't want to be, just imbibing pure sugar. Okay, being fat, because that'll elevate lipids and other things. But okay, then what's this over here? The lower part of the seesaw. This is what's called the AMPK pathway. So ATP, adenosine triphosphate, is a $20 bill energy in a cell. But AMP means you've lost 2 phosphates. So instead of adenosine tri as in 3 phosphates, and then adenosine diphosphate would be 2. Adenosine monophosphate is only 1 phosphate. And so that is a low energy phase in a cell. So what happens is after you exercise, you're running around doing whatever you're doing for exercise, your body's tired. And then what happens is you get this takeover of the AMPK pathway, which says, hey, energy levels are low. We don't have enough energy to grow or build or replicate, none of that stuff. All we need to do is rest and rebuild our ATP stores. Okay, so that's going to divert your energy resources of your blood towards the cells, your muscles that need to recover from the workout. So that's good. In addition, if you think about it, you have a heart, okay, in your chest that pumps blood all over your body. But you also have a lymphatic system that runs parallel to all your vessels, and it does not have a heart. Everything in your lymphatics runs based on contraction in your muscles. So when you exercise, you're contracting all these muscles, and that's causing flow in your lymphatic system. And your immune system travels all over the body, removing cancer cells. It's exactly what you want. It can increase immune system flow 10 to 30%. So you want to exercise your butt off, all right? But get your sleep, okay? Because you're also recovering and healing during sleep, and your brain cleans itself during sleep. So to feel good, you got to get your sleep. So I tell you all these things because this is a lot of stuff you could do, okay? And then having a sense of love and peace and purpose in your life, all those things lower your stress level, okay? You say, my life has meaning, okay? Your life has meaning based on your relationships, based with other people, based on helping other people. based on your relationship with God. And so all of those things help you, okay? And religion, people live longer that are religious. All the longest lived populations are all religious. Don't listen to these modern, ignorant jerk-offs who think atheism's good or atheism's real science. It stinks, okay? It's a fake lie of the modern world. All right, so I tell you these things because these are ways you can get yourself. Like my mom is a perfect example. She did everything right, except I was a dumbass, and I didn't know about this stuff back then. And I wish I had. She was real religious. She exercised a lot, and she was going around helping people all over the place. Okay. And also, just to mention, things that speed up mTOR, they also accelerate aging. You should know about the Hayflick limit. Hayflick was a molecular biologist working with human tissue cultures, and he found that human somatic cells, that means non-stem cells, non-germ cells. A stem cell is one that's enabled to continue to replicate a germ cells like from your testes or your ovary. They could only divide about 60 times and they die. So 60, all right? So what does that mean? If you're accelerating mTOR in these somatic cells, they're going to accelerate the rate at which they reach 60 cell divisions and die. You don't want that. Okay, so that's another reason why meat causes accelerated aging. All right, let's see what else. Exercising, you shut off mTOR, turn on the AMPK pathway, and I talked about that. That's what you want. Another thing about exercise, it just makes you smarter overall, helps you maintain your cognitive function. You guys probably seen this picture. Here's a sea squirt as a juvenile. It swims around and has a brain. As an adult, it attaches to a rock, becomes a filter feeder. Its brain is reabsorbed. If you're not going to run around, then what do you need a brain for? We talked about it too. Voltaire's quote, why does an animal have a brain but plants do not? Because an animal moves. As soon as you move, you need a brain because you have to make a value judgment. I'll go towards the fruits. I'll stay away from the bad stuff over there, the coyotes. You have to navigate. You have to avoid obstacles. You have to remember where you came from to find your destination back home. So you need a brain. So anyways, it's another reason why you want to exercise. Okay. Exercise does lots of good things for the brain. What else does exercise do good for the brain? It increases BDNF, brain-derived neurotropic growth factor, helps neurons to grow, enables forming new neurons, facilitates synaptogenesis, forming new synapses, facilitates brain angiogenesis. This is a good type of angiogenesis to maintain good blood supply to those brain cells. Increases brain glycogen storage, a good thing, especially in supporting cells, the astrocytes, okay? It increases brain's cells' mitochondrial biogenesis, making more mitochondria so they can produce more ATP. This is all good. Imagine if you had Parkinson's disease. You would want this, okay? It's one of the best things you can do for your brain. Also having intelligent conversations, all of that stuff helps. Let's see what else. It also facilitates glucose getting into the brain cells, what you want, okay? Okay, now I'm going to show you a couple books. These are some famous books. Here is this lady, Ruth Hydrich. She's a lady from Hawaii who survived metastatic breast cancer for decades, and she's like a world famous triathlete and marathoner, won lots and lots of races. And just look at this picture. She's doing a lot of things right. She's getting her sunshine, which is going to increase her endothelial glycocalyx sulfation or zeta potential. It's going to increase her systemic nitric oxide vasodilator to optimize her blood pressure, optimize tissue perfusion, tissue oxygenation, okay? Here's a lady, Janet Murray Wakeland. She wrote a book called, this is her website, Raw Vegan Path, but she calls her book Raw Can Cure Cancer. She's the one who ran, this is her husband, they ran together 365 marathons. That's a pretty fit couple there. Okay, she's probably about, I don't know how old, she's about 60 years old there, running 365 marathons in a row, pretty impressive. Here's Lorraine Day, another low-fat vegan who, survived metastatic cancer for multiple decades. Metastatic cancer. We're not talking about little primary tumors. We're talking about metastatic cancer, okay? Here's this book called Tripping Over the Truth by Travis Christofferson. And he's a very bright guy, and I think he knows Thomas Seyfried, the guy who did research on the metabolic theory of cancer. And I think they did a great job of explaining the basics of cancer pathophysiology and the metabolic theory of cancer. But I think after that, they go off the deep end, jump the shark, or whatever the heck you want to call it, and they start recommending the ketogenic diet. And I'm sorry, but I think they're profoundly ignorant about metabolism and nutrition. Okay, this is just a quick picture of how sunshine helps you. We talked about it. Increasing vitamin D, which is good for your immune system function, increases nitric oxide, increases sulfation of your endothelial glycocalyx. That's all good. Okay, here was the picture of what I had spoke about earlier, how an egg white has no iron in it, so that even though bacteria can get through the shell, they can't get to the embryo. And our body does the same thing to prevent bacteria from growing inside our bodies. We sequester iron. We keep iron bound in cells to ferritin. We keep iron in our blood bound to transport proteins called transferrin, so that it's not accessible to the bacteria. And it's kind of like if a human tried to cross the desert, they couldn't go too far because there's no water. So that's like a bacteria. It can't go do much in our body because there's no iron available. All right. Now here's the fact that humans in Western countries tend to be totally iron overloaded. Men, as soon as they stop growing at 20, they become iron overloaded pretty fast, most of them, because there's tons of iron in the red meat. There's lots of iron also in all these iron fortified foods, for example. Women don't tend to become iron overloaded in Western countries until after menopause. Then they rapidly become iron overloaded. And that's bad. I'll show you why that's bad in a moment. By the way, just a little bit about what's in foods. Meat, the hemoglobin right in the center has iron. Iron has a variable valence. It's a transitional metal, so it can have, like, most commonly a 2+ or 3+ valence, and that facilitates its ability to bind to oxygen. So here's iron in the center of hemoglobin bound to oxygen, okay? And it has a delicate on-off mechanism, so it can release the oxygen also to the tissues to supply them with oxygen. That's what hemoglobin does. But look at the plant in comparison. It's got magnesium in the center. So think about that. Meat, right in the center of its hemoglobin molecule, has something bad, iron. We really are iron overloaded. It's rare, other than, like I said, a menstruating teenage female who might become anemic. Most Americans by far are iron overloaded. Okay, premenopausal women are sort of the big exception. Okay, and most of them probably should have a lower hemoglobin than what the normal recommendations really are. So if you have a so-called mild anemia, it might not really even be a real anemia, but that's a topic for another day. Okay, well, anyways, you get the good thing. You need magnesium. Most Americans are deficient in magnesium. That's a vasodilator, and you need that also to help all your sodium, potassium, ATPase pumps function normally, okay? All right, so here's showing why is iron such a bad thing. Because iron can undergo what is called ferrous redox cycling, where it cycles back and forth between Fe2 plus and Fe3 plus, Fe2 plus, Fe3 plus, and in so doing, it gives an electron to the oxygen, all right? And it can form these free radicals, and these free radicals can be made into hydroxyl radicals, OH minus with an unpaired electron in the outer orbital. The point being is, this is hyperreactive. It's like taking a super ball and bouncing it around in a shop that sells glass products, okay? It'll just smash into everything and start breaking stuff. That's what these free radicals do. So when you have an excessive amount of free iron, you get an excessive amount of hydroxyl radicals, and they just damage whatever's in their vicinity. If it's in the mitochondria, it might damage the mitochondrial DNA. If it's in the cytoplasm, it'll damage cytoplasm structures. If it's in the blood and the plasma, it'll damage, let's say, endothelial cell membrane. So this is the great danger of having high iron available. Iron's like a fire. This is what Eugene Weinberg said. He wrote a book about this. There's been a whole bunch of books written on iron biochemistry. But basically, you want fire in your fireplace. You want fire in your stove. You don't want fire all over the place. Okay, so that's why high iron overload, as most Americans are, other than premenopausal females, it's bad. Because you get increased oxidative stress. And the older you get, the more of it you have, and the more damage it tends to cause. And that's also why old people sometimes start just rapidly going down the tubes, because you superimpose all these problems together, comorbidities, and they no longer have the immune system to sort of fight it off. The older you get, the more fragile you get. So the more things you better be careful to do right so you avoid all these problems. So here's in the mitochondria. You're going to leak some electrons off the intermitochondrial membrane electron transport chain. So here's electron transport chains, like a fireman bucket brigade, handing off the electrons to progressively more aggressive grabbers of electrons, and eventually finally oxygen, the ultimate electron acceptor, and that being converted then into water in the process. And that's all good. That's what's supposed to happen. And in the meantime, protons are pumped into membranous space, and then one is brought back across that direction, across the gradient, to make ATP. That's how the mitochondria makes energy. Anyways, what I'm saying is you'll sometimes get electron leak off the transport chain, and it'll hit an oxygen in the mitochondrial matrix and produce a superoxide. Okay, here's a superoxide, O2 minus, with an unpaired electron in the outer orbital. And you've got enzymes to neutralize this, like superoxide dismutase right here. Glutathione peroxidase catalase. That's all good. That's what normally happens. A little bit of this happens all the time in a normal cell. But when there's excessive amounts of this, due to, for example, excessive dietary fat will inhibit this, okay? Then, complex 3, you're going to get more electron leak, and you can get to the point where it's overwhelming, and then you can sometimes get excessive iron in your mitochondria, and then you'll start generating lots of hydroxyl radicals, and they'll trash your mitochondria. Okay, so this is how things happen. There's sort of like a ramped up, amplified cascade, and excess dietary iron does that. Okay, here's dietary iron in the cell. We absorb it in our duodenum primarily, and then it goes into the duodenal lining cells. The gut's called the enteric tract, so these are enterocytes. And then there's something called ferroportin. Ferro meaning iron, portin is a door. And when the door opens, it allows the iron to go into the blood. The little transferrin are carrier proteins. They look like little kayaks. You can think of them being like a robo. Randall Laufer, he's a big sort of famous author on biochemistry. He liked to call him a wheelbarrow. There's a guy named like Vernon Liu. He's a real brilliant hematologist. He likes to call them kayaks. You can call them different things. Either way, they look like a little kayak canoe boat to carry 2 iron molecules. And then they take the iron molecules where they need to go, to the bone marrow, to be put into red blood cells to work with hemoglobin for carrying oxygen, or a little bit to each cell to make its electron transport system iron-based carriers, and just a few other locations for the few other things it needs to do. But this is what you don't want, NTBI, non-transferrin bound iron, because that's the stuff that's floating free in the blood and can undergo ferrous redox cycling. So anyways, the whole point of this is you don't want free iron because it makes everything worse. And then the one point I'd probably get at, and I'll probably stop this lecture with this slide here, is just to show you this is what's happening in the real world. There's all these little things, sort of, trying to gang up on you and make you sick. So you got to be smart and avoid them as best you can. Like here's trichloroethylene, TCE, and that's from like dry cleaning, a lot of solvents and cleaning chemicals. Avoid that stuff as best you can. If you have to work with them, open the door, open the window, ventilate, maybe put a fan, blow it away from you. Okay, because all this stuff adds up. If you're eating high fructose corn syrup, it might have mercury in it. That's also going to inhibit complex 1 of the intermitochondrial membrane here. Okay, glyphosate on non-organic food inhibits complex 2. Cadmium, more common in non-organic food, inhibits complex 3. High dietary fat, SAF fat especially, inhibits complex 3. Atrazine on the non-organic corn inhibits complex 3. Lead, which is a contaminant in a lot of things, including potentially in this A-pill stuff, inhibits cytochrome C. F- in tap water. Okay, that's inhibiting over here. Lead, and then HNE, hydroxynonenal from the omega-6 oils, especially from omega-6 oils, will inhibit the ATP synthase. So what I'm saying is, and then here's the iron having its role to create the Fenton reaction, Fe for ferrous for iron, as well as Fe for Fenton reaction to produce hydroxyl radicals, which can damage membranes through lipid peroxidation. So what I'm saying is all these little tiny things are trying to nickel and dime you and damage your cells. So you want to avoid all the ones you can as best you can. And that's how you do as well as you can. Your body's got a lot of reserve. I mean, the human body's designed to survive despite, relatively harsh adverse conditions. But the smart move is to try to help it. Okay, and again, I've got movies about all this stuff at my YouTube channel, and I do have some movies at other channels like Rumble and BitChute and a few other places like LinkedIn. So anyways, I hope this was helpful. We talked about how to shut down mTOR. We talked about how to improve immune function, lymphatic function. We talked about the benefits of exercise. We talked about the importance of lowering iron. I just showed you here this slide about all these mitochondrial inhibitors, and this is why you want to eat organic as well and low fat as well. So that'll cover it for this as part 3. So I hope that was helpful.